In this video, we are going to learn how to compare functions, or we are going to compare functions, so let's begin. We can compare functions by looking at their properties such as their slope or rate of change. Remember, slope and rate of change do mean the same thing, okay? Slope, rate of change. To find the rate of change or the slope, we are going to use the slope formula, which is y2 minus y1 over x2 minus x1. Or compare the ratio of their rise over their run, also known as their change in y over their change in x. So let's practice finding the rate of change in the following examples. Rate of change when an equation is written in y equals mx plus b form, like this one. Remember, y equals something x plus b. Remember, the m is the slope, right? So the slope is always multiplied by the x. So in this equation, we have y. Oh, there's the slope. It's just multiplied by the x. It's 2/5. So the rate of change or slope is 2/5. It's a weird-looking 5. There we go. Ooh, we're given a point. That means we actually have to do some work to figure out the slope here. So let's use the slope formula. So it's y2 minus y1 over x2 minus x1. So it's the change in the y over the change in the x. So my change in y, let's look. This is y2 and this is y1. So it's 9 minus 7.5. And this is going to be x2, and this is x1, over 6 minus 5. 9 minus 1.5 is, 7.5 is 1.5. And 6 minus 5 is 1. So my rate of change is 1.5 over 1, or just 1.5. That's it. They give us a table. What's our rate of change? We have to look at from here to here and from here to there. 5 to 7 is they're adding 2. 7 to 9, they're also adding 2. I'm going to assume this has a constant rate of change. So from negative 5 to negative 11, how do I get from negative 5 to negative 11? I actually have to subtract 6. From negative 11 to negative 17, I'm assuming I have to subtract 6 again. That is correct. Now remember, it is change in y over the change in x, right? The change in y is negative 6. The change in x is positive 2. And it's that way for both of them. So negative 6 over 2 is our rate of change. And negative 6 over 2, if I simplify that, is just negative 3. So rate of change is negative 3. Rate of change for a line. I could figure that out by choosing 2 points that run through whole numbers or corners. Like this one's a good one. This is not good. That's not good. This isn't good. But this one is good. And I check for the rise and the run. What is my rise and run? Well, I go up 1. So that's the rise. And I 1, 2, 3, 4. I run 4. So my rise over run is 1 over 4. I cannot simplify that, so that's it. 1 over 4 is my rate of change or my slope. Use my knowledge of rate of change to help me compare the following functions. All right. Ty sells signs in a monthly craft fair, and he can make 7 signs every 2 hours. His friend Harrison helps him make signs, and the rate at which Harrison makes signs is in the table below. So Harrison's signs, every 4 hours he makes 15. 4 more hours, he's got 30. 4 more hours, he's got 45. So who is making signs at a greater rate, and how do you know? So they say that Ty is, his rate is 7 signs every 2 hours, right? 7 over 2. Harrison's looks like his signs, he goes from 0 to 15. That's plus 15. And then plus 15 again, and plus 15. This is a constant rate of change. And how many hours does it take him to make 15? Well, 4 hours, he makes 15. 4 more hours, he makes 15. 4 more hours, he makes 15. So the rate of change is just 15 over 4. It's a constant rate of change. So Harrison, he makes them at a rate of 15 over 4. 15 signs every 4 hours, whereas Ty's is 7 after every 2 hours. Who is making signs at a greater rate, and how do you know? Well, one easy way of doing this is sticking this in your calculator. If I just divided this in my calculator, 7 divided by 2, that gives me 3.5, which means he's making 3.5 signs every hour. If I divide 15 by 4, I get, let me stick this in my calculator, he makes signs at a rate of 3.75. You can have also figured that out by like, well, you know, if Harrison makes 15 signs after 4 hours, Ty, after 4 hours, he makes 14 signs. So Harrison actually makes more signs. So who has the greater rate? Harrison. How do I know? Well, I just proved it right here. Ty's is 7 over 2. Harrison's is 15 over 4. And if I just simplify that to a decimal rather than having a fraction and comparing fractions with unlike denominators, Ty only makes 3.5 signs every hour, whereas Harrison makes 3.75 signs per hour. After 12 hours, would the difference in the number of signs that each friend had made, what would be the difference? So we're asking how many signs would Harrison and Ty have made after 12 hours, and what's like the difference in the two signs? So we know Harrison would have more, but how many more? So let's figure out how many signs Ty makes after 12 hours. So I know that Ty makes 3.5 signs after 1 hour. So what I'm going to do is I'm just going to do like 3.5 times 12 hours, which gets me, that's calculator work, that's 42. This is Ty, by the way. Ty makes 42 signs after 12 hours. And the Harrison, he makes 3.75 signs times 12. And I could have figured this out by doing like 4 times 3, which means I multiply the top by 3 as well. But I didn't, so I'm going to do it this way. 3.75 signs per hour times 12 hours. He makes 45 signs. So what would the difference in the number of signs that each friend has made? That's basically 45 minus 42, which is 3. 3 signs. So after 12 hours, the difference between those two is only 3 signs. Let's look at the next example. Julie's family is filling up the pool in her backyard. The equation y equals 8400 plus 5.2x can be used to show the rate at which the pool is filling up with water, where y is the total amount of water in gallons and x is the amount of time in minutes. Her neighbor Elena is also filling up their pool as shown in the table below. So whose pool is filling up faster at a faster rate, and how do you know? So we need to figure out the rate of change for both of them. So Julie's rate, remember the rate of change is in the equation and it's what's multiplied with x. So Julie's rate of change is 5.2. So this is Julie's rate of change is 5.2. 5.2 gallons per minute, it sounds like. Gal per minute. And let me do a different color for her friend who is Elena. L is what we'll call her. The rate of change is, I actually don't know. Let me subtract 7864.4 minus 7850. I'm going to put that in my calculator. 7864.4 minus 7850. What is the rate of change? That's 14.4. And this is plus 3. So this goes up by 14.4. That goes down by 3. This is weird. This is going up by 2 now. And this also is, well, let's do 7874 minus 7864.4. So that's a rate of 9.6, and that is a rate of 2. Well, that isn't super weird because the x changed, but if I divided the y over the x for both of these, it should be the same. But let's go ahead and check this last one, just for the fun of it, even though I technically don't have to because I can find my rate of change from just dividing that 14.4 by 3 or 9.6 divided by 2. But let's go ahead and just kind of, just for the fun of it, that's a change of 2, and this should be a change of 9.6. So let's subtract 7883. 7883.6 minus 7874. And I am correct. That is a change of 9.6. So, Elena's rate is, let's just do 14.4 divided by 3. And 14.4 divided by 3 is, oops, accidentally typed the wrong thing on the calculator. 14.4 divided by 3, and that is 4.8. That's 4.8 gallons per minute. So, whose pool is filling up at a faster rate? Well, Julie's is 5.2, Elena's is 4.8. It's Elena's. Sorry, it's Julie's. My brain is gone. Julie, her pool is filling out at a faster rate. How do I know? Well, I just proved it right here. Elena's is only going up at a rate of 4.8. Julie's has a rate of 5.2. All right, number 7, comparing the slope in each of the equations below. Circle the equation that has a greater rate of change. Show all work. Okay, this is where we get a little weird. I know I said that slope is what's multiplied by x, but that's only if, but that doesn't mean the slope over here is -9, and that slope is -3. It's because you have to get the equation to be written in the form of y equals mx plus b. And in this equation, y needs to be by itself, and it needs to be on the left side. So what I need to do is basically I need to make sure y is on the left side of the equal sign and by itself. So y, this 3y, this needs to be here on the left side of the equal sign, and I need to get rid of that 3. So what I'm going to do is I'm going to, before I get rid of the 3, I need to move over the x. So I'm going to move over negative 9x by getting rid of it, plus 9x and plus 9x over here. So I'm left with 3y equals 9x plus 27. You may be thinking, like, isn't that 27 plus 9x? Sure, it doesn't matter the order, actually. Next, I need to divide both sides by 3. So divide this by 3, and I basically have to divide everything on the other side by 3 as well. I'm left with y, because 3 divided by 3 is 1, and 1 times y is y. 9 divided by 3, can we simplify that? We can. That just equals 3x, and 27 divided by 3 actually equals 9. So my slope is that 3 right there. Okay, let's take a look at the other rate of change. I need to do the same thing over here. I need to get the y by itself. So get rid of the other stuff. I need to get rid of the 3x by adding 3x to both sides. And I end up with 4y equals 3x plus 24, or 24 plus 3x. Both mean the same thing. And now I have to get rid of 4. I need to neutralize it, divide it by 4. 4 divided by 4 is 1. Divide this by 4, divide that by 4. Here's the thing. You actually don't even need to simplify this. What's 3 divided by 4? It's just 3/4. You can't simplify it further. So this has a slope of 3, and this has a slope of 3/4. Which slope is greater? This one is greater. So this one has a greater slope. Ta-da! Because this one is 3/4. All right, let's take a look at number 8. Compare the slope in the equation with the slope shown in the ordered pairs below, which has a greater rate of change. So this slope in the equation is just 3/5, because it's already written in that nice y equals mx plus b form. To find the slope of this, we need to use our slope formula, and we need to choose 2 points. Which 2 points am I going to use? I'm going to choose points with, I was going to choose points with whole numbers, but I guess this one and maybe this one. Sure, why not? Let's make this one, so remember it's y2 minus y1 over x2 minus x1. And y2, let's make this y2, and let's make this y1. So 6.2 minus 5 over 7 minus 5. So 6.2 minus 5 is 1.2. 7 minus 5 is 2. If I simplify that further, it is 1.2 divided by 2 is 0.6, I'm thinking, but I'm going to stick it in my calculator because I am not confident. This is a slope of 0.6. 3/5. Oh, I don't like to compare fractions, so how do I turn this into a decimal? Well, you just divide it. 3 divided by 5, whoops. 3 divided by 5 is 0.6, actually. 0.6. They're both, look at that. They're both 0.6. Which one has a greater rate of change? Neither. They're both equal. Last one. Story about Reese and Kevin. They've been working out together to try to lose weight. Reese's weight loss can be modeled by the equation y equals 203 minus 4x, where y is his total weight and x is the number of weeks he has been working out. Kevin's weight loss progress is shown in the graph below. Who is losing weight at a faster rate? Explain your reasoning. Okay, this one's easy. Take a look at that. The slope is multiplied by the multiplies with the x, and that is they said that's Reese's weight loss is modeled by the equation. So Reese, I didn't even need the s, but whatever. His rate of change is -4, and Kev's rate of change is figuring out in the graph. So he starts off at 200, looks like, and then we go down. This isn't a good point. This isn't a good point. This is a good point to compare to. So my rate of change, or my slope, is I'm going down by that much, and I'm going over by this much. So 4 weeks, and then it's not -1 over 4 because it goes from 200 to 180, so that's actually -20 over 4. So my slope is -20 over 4. Can I simplify that further? I can. -20 over 4 is -5. So Kev has a weight loss of -5. Who is losing weight at a faster rate? Kevin is. Explain your reasoning. I just did. This one is -4. This one is -5 based off of the graph. So Kevin's losing weight at a faster rate. And that is our notes on comparing functions. Go ahead and try some problems on your own.